Alright, in this video you're going to learn how to do difference quotients, and the reason that we're doing it in this section is because when you do difference quotients, it's kind of like working with either complex fractions or adding and subtracting rational expressions. It's a lot of that kind of math, so we do it after we learn how to do that, just because you wouldn't know how to do these otherwise until we had already done what we just learned. So these are really important in calculus, and so whenever I ask you to evaluate the difference quotient, you can do that for any function that I give you. Some are going to be harder than others, but this is the difference quotient. Now, this actually represents something, and you'll learn what it represents in the third video that I have you watch on haiku. It may end up being the second video. I'll put it on there, but it does represent something. But in this video, I'm just going to teach you kind of how to evaluate the difference quotient and what it is and how to do that. So before we start that, let's go ahead and do just a quick function review and talk about what these things mean. So if you were trying to do f of 3, you all know that f of 3, that's just telling you to plug 3 in for x. So this would just be 2 times 3 plus 5. So that would be 6 plus 5, which is 11. And that's simple. Same thing with f of negative 5. That's just telling you to plug in negative 5 for x, and then figure out what that is. So 2 times negative 5 is 10, plus 5 would be a negative 5. Now, down in number 3, this really just means the exact same thing that this meant, except now there's an x in there with the number, okay? So this does not mean to take 2 and multiply it by everything in here. It doesn't mean to take 2x and multiply it by this. This means to take 2x and plug it in 4x into that function. And so when I simplify this, the only way I can simplify it is just by multiplying the 2's and making that 4x plus 5. And then that's as simple as it can get. So that's the simplified f of 2x. And then same thing with the next one. This is just telling me, okay, I need to plug x minus 5 in for x. So this would be 2 times x minus 5 plus 5. So this would be 2x minus 10 plus 5. All I did was distribute this 2. So this would be 2x minus 5. And then this next piece, this is the first part of the difference quotient right here, f of x plus h. And so this is how you would do one of the first parts if I was asking you to evaluate it for this function. So I'm just going to take x plus h and plug it in for x. So 2 times x plus h plus 5, and simplify that. So this would just be 2x plus 2h plus 5. And there's nothing else I could do with that. I can't combine like terms, so that's my answer. So this is just kind of a review to help you prepare to be able to do the difference quotient for something like this. I'm going to write the difference quotient down. It's f of x plus h minus f of x over h. So I'm just going to take this a little part at a time, okay? So right here, f of x plus h, I'm just going to do that first. That's exactly like what we had right here, f of x plus h. And so this first part is just telling me to take my function, and in for those parentheses where there was an x, I'm going to plug in x plus h. Okay? And so all of this was just my f of x plus h. That's what that is. Now, minus f of x. So I'm going to subtract. F of x is just this original function. But what you have to make sure that you do is whenever you subtract that, you have to subtract the entire function. So I'm going to put this in parentheses and distribute the negative to everything. You've got to make sure that you do that. So then this is all over h. And this is just h right here. It's not f of h. It's not telling us to plug h in for anything. It's just h. So I'm just going to put h in the bottom. And now, whenever you do these, I kind of like these because I think they're real fun. You should get a lot of stuff that cancels out. And so if you don't get a lot of stuff that cancels out, something is wrong. But on this one, you should get 2x plus 2h plus 1 minus 2x minus 1, where I distributed that negative, and then divided by h. And so these are going to cancel out. My 1's would cancel out. And so I'm left with 2h over h. Now my h's will cancel out, and so my final answer on here would just be 2. Now, this is a linear function. You won't always get just a number for your answer unless you have a linear function. So because this is a linear function, you just get an answer. But if you have a function that's like this, for example, this is a quadratic. I'm not going to get just a number on this answer. So let's do the difference quotient. I'm going to write it down, f of x plus h minus f of x over h. So now, this first piece of the function is just telling me to plug x plus h in to all of those parentheses. And so this, a lot of people will do the f of x plus h part and forget the minus part. So you need to make sure that you know which part is which and you have everything that you need in the top. I'm going to go ahead and plug in x plus h here. And now this minus f of x, I'm just going to minus all of my original function here. And then I've got to put it all over h. Now, in order for me to multiply this out, do not get this, x plus h squared, confused with x squared plus h squared. Those are not the same. So this is not what you can do. That is wrong. What you would need to do is take x plus h, write it out twice, and then you would FOIL that. I'm going to go ahead and FOIL it over here in the corner for my little side work, and then put it back into my problem. So this is going to be x squared. The outsides would give me plus xh. The insides would give me plus xh. And then my last terms would give me plus h squared. These two in the middle are going to combine to be 2xh. So right here, this is what I've got in my fraction so far. X squared plus 2xh plus h squared. Now I'm just going to go ahead and distribute, since that's easy distribution for the rest of the problem. So this is going to be minus 4x minus 4h plus 7 minus x squared plus 4x minus 7. Alright, so now that I've distributed everything in the top, this is all over h, and I can go ahead and combine like terms in the top. And remember, this is where you should have a lot of things to cancel. So my x squareds are going to cancel, my 7s are going to cancel, my 4x is going to cancel, and that's it. Okay, so everything that I'm left with, 2xh plus h squared minus 4h all over h, that's just going to end up being what all I can combine in the top and put in the top. But they all have an h, so I can factor out an h. And the reason that I'm going to do that is because when I factor that h out, it can cancel with this h in the bottom. And so it'll leave me with what my final answer would be. So this right here is going to be my final answer, 2x plus h minus 4. And you need to make sure that you factor out the h before you cancel it, or it's not going to, probably won't be right. So this is going to end up being 2x plus h minus 4 is my final answer. Now, at this point in class, I would show my kids what the difference quotients video is, that one that I'm going to have you watch to explain what it actually represents. And so if you wanted to stop this and then go watch it and then pick back up here, I think that'd be a good idea. I'm going to go ahead and finish the examples that I have. And so these last two examples are examples of harder functions to evaluate the difference quotient for. And it kind of like takes everything that we've done with complex fractions, adding and subtracting rational expressions, and puts it all together. So again, my difference quotient is this. And so the first part, I'm going to take x and plug in x plus h right there. So right here I'm going to have x plus h minus 3. And I just took this x plus h and plugged it in right here for x. So this is what I have for f of x plus h. Now, minus f of x is just going to be my original function, and then all of this is over h. So I'm going to go ahead and right here, a lot of people think that they can just say plus h over here and have the same denominator. That's not going to work. You can't just add h to each side and keep the equality of the fraction. You have to go through the process of getting a common denominator. So this side would need an x minus 3, and this side would need an x plus h minus 3. So then across the top, this is going to end up being 3x minus 9. Now, what a lot of people are going to miss here, and you need to be sure you don't miss because it'll throw you off every time, is when you distribute this negative 3, you also have to distribute this negative with it. If it helps you to do plus a negative right there, to see it beside each other, do it, but you have to distribute that negative in there. So this is going to be negative 3x minus 3h, and then plus 9. Okay, and I just distributed that negative in with everything. Now, this is all over my common denominator, x minus 3 and x plus h minus 3, and then it's all over h. So then, my 3x's in the top cancel out, my negative 9, positive 9 cancels out, So negative 3h over x minus 3, x plus h minus 3 is in the bottom. I'm going to go ahead and take this h over 1, select an h over 1 there, and flip it and multiply, so 1 over h. My h's are going to cancel out, and so then I'm left with this, negative 3 over x minus 3, x plus h minus 3, and this would be my final answer. Alright, and then our last example, here. This one is a little bit challenging also. This one's probably one of the harder ones that I would give you. But I'm going to write my difference quotient down, f of x plus h minus f of x all over h. So when I plug in my x plus h, this is going to give me 2 over x plus h squared. That's f of x plus h. I just plugged x plus h in for x. Minus my original function, so 2 over x squared over h. Now this is real similar to our last fraction, or our last problem. But instead of going ahead and multiplying this out in the bottom, I'm going to go ahead and get my common denominator first. So this needs an x squared, and this needs my x plus h squared right there. So now, when I distribute across the top, in my first fraction, I'm going to have 2x squared. Now right here, in order for me to be able to distribute this negative 2 to the x plus h squared, I have to know what x plus h squared is. And so we did this in example 2. We did x plus h times x plus h and multiplied that out. And you should get used to multiplying this out, because in quite a few problems that I give you, you're going to have to be able to multiply this out. So again, this is just going to be x squared. Outsides give me xh, insides give me xh, so this is going to be plus 2xh. And then h times h is h squared. And so then that's really what I'm distributing my negative 2 to. So this is going to be minus 2x squared. This is going to be minus 4xh. And then minus 2h squared when I distribute the negative 2 to this. Okay? So that's what I have in the top. All over, I'm just going to leave my common denominator, x squared, x plus h squared. You could also factor it out. You could put x squared plus 2xh plus h squared there, and it would be the same thing. I just don't like to write it all out. It makes it look a lot bigger than it is. So I just leave it like this, and it's fine to do that. The 2x squares are going to cancel out, and so in the top I'm left with negative 4xh minus 2h squared over my common denominator. And so then I'm going to go ahead and flip this and just change this divide to multiply. And so then I'm going to factor out my h in the top. You could also factor out a negative 2. Either way, it really doesn't matter. I'm going to go ahead and factor my h out here, and that's going to leave me with negative 4x minus 2h. And so this h and this h are going to cancel out. So what I'm left with in the top is a negative 4x minus 2h over my common denominator. And so there's my final answer. Now, if you didn't watch the video on what this actually represents, what the difference quotient represents, then you should do that, because it's really, really, really important in calculus. This is basically like the definition or part of the definition of a derivative, and you'll spend probably the first entire half of calculus on derivatives. And so it's real important that you kind of be good at this right now, because it's real important when you get to calculus.